Hello, this is Susan Poss again, and I'm still working in section 9.4. This is the third video. I left the previous example from the previous video on screen here because I had written an equals sign here as though there was additional work to do. There is not. That equals mark should not be there, and this 5 times the square root of 3 plus 3 times the square root of 2 is the final answer, again, because the radicands do not match and the terms cannot be combined. All right, so moving forward, this next example is cube roots. So I need to think through my perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and so forth. So there's a little quick list of perfect cubes. So I'm noticing this is subtraction. See the minus in here. I'm noticing that the indices, the index numbers, are both 3s. But the radicands do not match. One is a 5x and one is a 40x. So let me see if I can do that simplifying. Note here, I'm working this time with cube roots. All right, so I don't think I can simplify 5x because I don't see anything in my list of perfect cubes over there that is a factor. But I can work on 40 using 8 times 5. And of course, you see that 8 is in that list of perfect cubes over there. And let's just talk about that quickly. You would not want to use 4 times 10 because neither 4 nor 10 is in your list of perfect cubes, right? You would use, if this were a square root, then you would use 4 times 10. And you'd be able to take the square root of 4 there. So try to keep track of what the index is so that you'll know whether you should be looking at your list of perfect squares or your list of perfect cubes. All right, so back to the problem. I'm going to leave this the cube root of 5x. I cannot simplify that. Minus, here's the cube root. This is where I like to do a little separating out. I'm going to leave the 5x there because I can see that that's where these things are going to match up. They're going to have the same radicand and the same index. I hope you see this is the first term, and all of this is the second term, and here is the separating operation in here of subtraction. All right, so in the second term, the cube root of 8 is 2. Leave the cube root of 5x, leave the minus, leave the cube root of 5x. All right, so now I have 2 terms. Here's the first term, here's the second term. They both have an index of 3, they both have a radicand of 5x, and there's one little trick here. The number out in front that you don't see is a 1. So when you start to combine these, you're going to have a 1 minus 2. So that's kind of a tricky thing to remember. That 1 has been there all along. There was just no reason to write it down. It's just like a 1x. You don't normally write the 1 down, but you need to be aware of it. So the final answer here, when I do the operation of 1 minus 2, I get a negative 1. And this just remains the cube root of 5x. Now, you generally, again, don't write the 1, so the best form of your answer, don't lose the negative, that's important, but the best form of your answer is going to be negative the cube root of 5x. right, so let's see if we can squeeze in one more on this video. We're back to square roots here. These have a lot of variables in them with powers. And you can see the square roots match. The indices are both 2's, but the radicands do not match. So this one's kind of tricky. All right, so we're back into square roots. I'm going to think of this as the square root of 4 and the square root of y cubed. I'll deal with that in a minute. The square root of x squared, the square root of y cubed. And again, I'll deal with that in a minute. So for now, I'm just going to work on the square root of 4 and the square root of x squared. All right, so I hope you're still with me. I'm going to take this x times 2 here and turn it around because we usually put the numerical coefficient first. Okay, so here's the other piece of this that we need to take care of. You can see in these radical parts, this is a square root, but the power underneath on the y is larger than the index 2. So we have to do a little bit more simplifying with that. So I'm going to split this up into, remember how we go with the next lower power? I'm going to go ahead and put that little 2 in there. So here you can see that y squared times y to the first, y squared times y to the first is still equal to y to the third back here in the previous radical. So let me do a little bit more simplifying, and then I'm going to combine. So here, when we do the square root of y squared, whoops, I don't like the way I wrote that. Try that again. I hope you recall that the square root of y squared is equal to y. Just like back up here, the square root of x squared was equal to x. And you can't simplify the square root of y because this index is larger than the power in the radicand. All right, so all of that work, now I can see that I have these radicands matching. Same radicand y, same index 2. And so the parts that need to combine are this 2xy minus 5xy out front, and then this square root of y just trails along here on the end. All right, so we're almost done. So this comes out to be negative 3xy times the square root of y, and that's your final simplified version of the answer. So again, watch out when you see a variable, when you see a variable that has a power that's higher than the index, you're going to have to do that simplifying process. So I hope maybe you remember something. If you have the square root of x to the 15th, you bring that down to x to the 14th and x to the 1st. And then when you take the square root of x to the 14th, you get x to the 7th. And the square root of x just remains out here on the end. So that's a process that's somewhere in your earlier sections. If you've forgotten that, you might want to go back and do a quick review.